Let's continue the projectile motion. Here we have to find out the time to reach maximum height and then time of flight of a projectile. Time to reach maximum height means from the starting point to the topmost point, the time taken. And time of flight means the time for which the projectile is in air, means from the starting point to the end point. So let's Tm be the time taken for the projectile to reach its maximum height, and Tf, or simply T, be the total time of flight of the projectile. At the point of maximum height, you know that the vertical velocity will be 0. So Vy will be equals to V naught sine theta naught minus gt by using first equation of motion. So you got Tm equals to V naught sine theta naught upon g, and at t is equals to Tf, the vertical distance will be 0, y will be 0. So by using the second equation of motion, 0 will be equals to V naught sine theta naught into Tf minus half g Tf square. So you got T is equals to 2 V naught sine theta naught upon g. Here you can see that the total time of flight is twice of the time of the maximum height because of the symmetrical nature of the parabolic path. Now maximum height of the projectile. Maximum height of the projectile is that point where the vertical velocity Vy will be 0, and by using third equation of motion, V square minus U square is equals to 2as. Here the vertical distance traveled is y, so Vy square will be equals to V naught square sine square theta naught minus 2gy will becomes 0 square equals to V naught square sine square theta naught minus 2g into hm, or simply hm, or you can say the h, maximum height, is equals to V naught sine square theta naught 2g. Now let's calculate the range of the projectile. Range of the projectile after time Tf means time of flight or the total time taken is a horizontal distance covered by the projectile from its initial position to the end point, or at which y will become 0. So x will be equals to V naught xt. By putting the value of V naught x, you got V naught cos theta naught into t will become r equals to V naught cos theta naught into tf, because now we are finding the range, means at end point the total time will become tf. So by replacing the small t by tf, r is equals to V naught cos theta naught into twice of V naught sine theta naught upon g, or simply you got V naught square sine 2 theta naught upon g. Here I have used the mathematical formula twice of sine theta naught into cos theta naught equals to sine 2 theta naught. The range will be maximum for maximum value of sine, because when the sine 2 theta naught will become 1, the value of range will become maximum, and you know that the value of sine 2 theta naught will be equals to 1 at sine 90 degrees. So the value of theta naught must be equals to 45 degree. Therefore the maximum range will be V naught square by g. Now range of projectile is same for complement angles of projection. We have already calculated that the range is equals to V naught square sine 2 theta naught upon g. You can see that if the angles are different, so the range is different. But if the angle is 45 degree, you can see, and the initial velocity is v naught. The maximum range covered by these is same, but the maximum height is different. For angles 45 degree plus alpha, 45 degree minus alpha, the 2 theta naught will become 90 degree plus 2 alpha and 90 degree minus 2 alpha. And the values of sine of these angles are same and are equal to cos 2 alpha. Therefore, ranges for these elevations are equal, which exceed or fall short of 45 degree by equal amounts of alpha. In other words, for complement angles of elevation, the ranges will be same. Now, this one is the another mode when you have given the horizontal velocity only. So, the projectile given horizontal direction. As shown, suppose a body is projected horizontally with velocity u from the point O at a certain height h above the ground level. Now, the body will move under the influence of two velocities, horizontal as well as the vertically downward accelerated motion with constant acceleration g. But the horizontal velocity is uniform. And under these combined effect, the body will travel the projectile path OPA. So, the trajectory will be again by using the equations of motion. X distance traveled will be velocity into time. And by using second equation of motion for vertical, you will get y is equals to g into x square upon 2u square. By putting the value of t from the above equation, you got, and this one is the equation of a parabola. So again the path followed is a parabola. For time of flight means the time taken from O to A. Again by using second equation of motion and by putting small t equals to capital T, you got capital T is equals to 2h by g. For horizontal range, horizontal velocity into time of flight, so r is equals to u into 2h by e. And for finding the velocity of projectile at any instant, the horizontal component, you know that it will remain constant equals to u, and the vertical component is equals to gt. So by using parallelogram law of vector addition, you got v is equals to u square plus g square into t square under the root. And if you have to find out the angle beta with the horizontal, then tangent beta is equals to perpendicular upon base. So you got vy upon vx, and that is equals to gt by u. So from here you can find out the direction. In the next video, we will do some numerical problems on these projectile motions. Thank you.